So before I get into that, I'll tell you how you should use it. Basically, if you're using a web app framework, chances are it already has that module or function provided for you. All you have to do is read the document, find out how to use it. Most of the time, what it really does is it generates a token of 3 things. Right? Your slides here. So this is it. So I'll briefly explain what's going on here in this math. So when you generate a token, it takes 3 things. The first is an application-specific key, which could be any password or random string that you generate that is specific to your application. So think of it as if you deploy on AWS, you probably know like you have a client ID or client secret or something like that. That's what it is. You have a secret, but hopefully it's distinct from your AWS secret, because in case your AWS servers go down, your application is not going to, or in case they penetrate your application and grab that secret, they're not going to be able to penetrate your AWS servers. You need a cookie that is unique to every browser session. That usually means your session ID. String delimiter, which could be anything that doesn't appear inside your cookie, or your third parameter, which is your location, which is just the path that you're willing to grant access to given that token. So what do you do with these 3 things? Well, you put them, you concatenate the cookie with the delimiter and the location, such that you can break them out afterwards. You initialize the MAC algorithm, and MAC is a message authentication code. The most commonly used one is HMAC. If you look into your favorite language, which hopefully is Python, there's a standard library called HMAC. Read the documents, find out how to use it. The way to use it is to initialize it with a key, which is K subscript MAC here. And then you update it with a message, which is the concatenation of C plus D plus L. And the third method that you call would be digest or hex digest, which will give you back a string. With that is your token. So that's a lot of words. Good thing is, most frameworks already do that for you. And I have to plug Blueberry Pie because I wrote it. But if you're using Django, there's a link there. Click it, find out what it does, how to use it. Flask, same thing. Don't invent your MAC implementation in case you have to do something that these frameworks don't take care of for you, or you're not using one of these frameworks. So when you have that token, you typically put it inside a hidden input element inside your form, so that when you submit that form, that token will go along with it. And that code below is how you break that token apart and find out, and then you get a cookie and a location. Right? With that cookie, you can find out the session, whether that's a valid session ID. But usually you don't check that. The only thing that you care about is your location. Right? So you break that cookie apart, you grab the location, then you grant access to it.
This is hands up who already knew about cross-site request forgery. Who's already doing this at the moment, or knows that they're doing this?
Yeah.
You've not seen this before. You've not seen it. We're using okay. So.
Yeah. Okay. Good.
Because I'm sure a lot of people are using it. I'm just not sure who's aware.
Right. Not sure a lot of people know what it does. So okay. So we're gonna go to another attack vector, which is cross-site scripting. So here's an example. You are the webmaster of example.com. Your site is not secure. You have a resource called blocks, which accepts a query string that basically searches a bunch of blocks for a keyword, in this case, apple, and some evil script that happen to be URL escaped. So what happens is, if you don't, so remember we talked about HTML injection before, right? So this is what happens if you don't escape your result. So suppose the result comes back as apple pie, and then you have that href anchor there, and then the script will actually get pasted directly into your result, and that script could be doing some really, really terrible things. So how do you prevent that from happening? In this case, always escape the URL on the server side, or unescape them. Or actually, I got that reversed. So escape a URL or HTML, escape them when you paste them into your HTML template. Okay. If that parameter goes into an HTML attribute, such as href or source, you HTML and encode, you URL encode them. Okay. So JavaScript has two methods that allows you to do that. Go to Mozilla's developer network site and find out what they do. There's some things that you have to take care of. In Python, it's battery included, so you can just import URL lib and a bunch of methods that you can use. URL lib.quote, quote your query string. Basically, URL encodes them into percent encoding. By percent encoding, I mean something like that. %3c, %3e, blah, blah, blah. Quote plus, that's a similar thing, except that it substitutes a plus sign instead of %20 for space. URL encode takes a dictionary of key value pairs and encodes them into a %encoded URL query string. Path name to URL encodes a path name, could be inside a URL or your OS path name into a form that should be displayed in an encoded URL. So so another thing to worry about is, so these days people use JavaScript templates a lot, or rather dynamically render JavaScript in the HTML template. So suppose that in your Python code you have a dictionary that has a variable, var, right? And then you have a string that starts with quote and then brace, bracket, blah, blah, blah. Basically things that you close a backbone model constructor. So if you look at the Ginger.js template down there, now you could do something like that. You could just basically turn that dictionary directly into string and then paste it into your Ginger live template. And the result is on the right-hand side. What you really want to do, or rather what you don't want to do, is to have people execute code arbitrarily, or inject code that could be executed arbitrarily by the client. So how do you deal with that? Depends on where your data comes from. If it comes from a form field that has that you can filter out with regular expressions, you could use solution 2. But the thing is, it doesn't understand Unicode in 2.x. That's kind of useless. Or solution 1, which is you could just allow anything that's alphanumeric and anything in the CJK code block or whatever, and don't allow any weird symbols. Solution 3 make sure your code is encoded and decoded with a proper JSON serializer, because inside a JSON string, the spec mandates that you have to escape the double quote. Okay, that means you cannot break out of a string when you paste it into a JavaScript or JSON. So solution for is don't write this code in the first place, because some people have CSS templates and JavaScript templates that is generated on the server. That's just very difficult to maintain. So session hijacking is also another attack factor that has a little bit to do with
we lost the sound on the Hangout.
why is everything mute?
Oh, okay. Now we can hear. Thank you.
Okay, is that good?
Yes.
Okay. I don't know why it went mute.
Yeah.
Kind of strange. But anyway, did you lose anything? Taiwan? Okay, I guess not. So, okay. So basically, typically, your web framework deals with session one or two ways. The stupid way that was done in the early 2000s by some Java servlet or Tomcat or whatever is to basically append your session ID on a query string, and then you bring it with you on every request and response. So basically what that means is that it spits out a URL to you with a question mark, J session ID dot some random number. And for every link you click on, that session ID is there too. So that's how you keep track of a session. That's rarely using. Most commonly is done by a cookie that has a session ID and an expiry date for you. An expiry date is important. There's this thing called persistent cookies, meaning you could say, I want to log into this site for the next 2 weeks. That's what it's used for. In general, the shorter the time window, the better, because you basically are limiting the amount of exposure or possible exposure of that cookie to malicious attackers. So here's one way to hijack a session. Getting your session hijacked is very, very bad, because once you get the session, you could pretend to be that user and do lots of damage. You could change that user's email, password, credit card information, or grab it, rather. So this is first scenario. Evil hacker goes to www.xaml.com, the session ID. The hacker sends Tom Cruise an email with the URL. Tom Cruise signs up to the Church of Flying Spaghetti Monster with that session. Evil hacker visits URL and change Tom Cruise password, or rather just let it stay there and see what stupid thing Tom Cruise does, and sell it to Hollywood Insider or something. Scenario 2, same thing. Substitute session cookie. Well, should be reversed. Substitute session cookie with your query string. Scenario 3 is a very unlikely situation. It's an exploit of your browser vulnerability. Suppose same origin policy doesn't work in whatever browser you use. A hacker will be able to potentially set a cookie with a session ID that they know beforehand to any arbitrary domain, could be Google or whatever, and send you an email, you click that link, and boom. So how do you prevent that? So if you go on Wikipedia, they tell you many different ways to prevent session hijacking. Some say, don't put your session ID in a get a post request. Some say always ask for an email or password. Don't do any of that. Only do this, which is generate a different session ID for every request. That basically means you have to. So the way that you keep track of your session is to have a table of all the session IDs that you last generated. Okay. And when one person comes in with a request with one of those previous session ID, you immediately invalidate it, meaning wipe it from your database. And then in your response, you generate a new session ID for that user. Okay? CherryPy, Blueberry Pie does that by default. I don't know anything about Django or Flask. I tried Googling it. I couldn't find anything. I'm not about to look into that code. So if you know anything, it's time to speak up. Yes?
How do you deal with HTTP failures with that?
You cannot. No.
There's a session you go back, you don't need to reload the page if you go back. If you do reload the page, you pass a new session ID.
Yeah.
So that button should work, but if you've any HTTP requests fail, then you're logged out.
Yeah, then you're logged out.
Okay.
But if you are legitimate, then you could probably log back in again, right? You just want to lock out the hacker. Do you have anything on that?
Well, I'm just wondering if you did if you kept a couple of previous sessions and then I mean, this is getting into a discussion.
There's actually a scheme that deals with login session cookies, but it's rather complicated. I don't think it's implemented by anyone. I think Drupal is, but we don't use Drupal.
Yes, it would do, because I said that.
No, it won't. It just gives you a different session ID.
If I open a Gmail window and I type an email, and then I open it in another page, I wouldn't be able to send that email.
You'd have to have multiple sessions per user account. And we basically track those sessions separately. So session 1 gets invalidated and does its update, where session 2 hasn't been changed, and it's a separate chain. That would be interesting.
Yeah, I mean, this is one way to deal with it, but you have just illustrated that it actually presents a lot of problems. So lots of web frameworks actually don't do it. All they have to do is keep track of a giant session ID table. That's it. So this is debatable.
Interesting.
Yeah.
Okay.
So I'll give it to
Sure. I think we're going to do a little bit here about hashes, passwords, and crypto. And again, I think for most of you here, it's going to be quite straightforward stuff. Just stop me if you want to explain anything more, but I'll go quickly through these. So, straightforward thing, never store passwords in plain text in your server. There is no need to do this. If you do this and your server gets compromised, they probably use the same username and password, a different site. You need to then mail your entire user base and tell them to change your password. That's pretty embarrassing. You probably still have to mail them anyway and tell them their email address has been compromised, but not their password. So hash the passwords. If you hash them, you convert a bit of text into a hash string. That same bit of text will always turn into the same hash string, but you cannot reverse that operation. So if someone finds that hash string 9E107, you can't get back to that original text, the quick brown fox. So it's a way to test for passwords and check them without exposing them. At the moment, SHA-256 seems to be recommended hashing algorithms. They always change over time, and old ones get compromised. SHA-1 and MD5 are kind of no longer recommended. For practical purposes, if you're using them, it doesn't mean you're necessarily vulnerable, but you're better off using 256 if you can. There's a couple of other new ones now. Salting. Hands up who doesn't know what salting is. Okay, so we've got one. When you actually encrypt that password, if you encrypt a quick brown fox, you encrypt that bit of text, it's going to turn into that result. What you do with salting is you add a couple of characters at the start, and then you hash that. And you store that hash and you store that salt. The reason you do that, if someone steals your password file, so let's say they get a database and they've got all encrypted passwords. If someone had the username of a password of let me in, then they're going to know what that turns into. And they're going to have a hard disk here with all those results. They do a quick comparison and they find anyone with let me in. If you've put some salt on there, there's no way they're going to have a hard disk with let me in plus this salt, and then let me in plus this salt, and because there's so much different variations in salt, you couldn't store all those possibilities. That's kind of called a sort of rainbow table attack for doing stuff like this. So if you salt your password, it stops one kind of attack on breaking into them. It helps a lot if your accounts are broken. And then for end users, prevent people from using Joe accounts, which is the same username and password, or let me ins and other things. It's usually sensible, but you can't solve end users entirely, unfortunately. So next thing is random numbers. It's different amounts and different types of randomness. Genuine systems, you'll have random numbers that are secure and random numbers that are not very secure. Python's library, the random library, by default gives you kind of insecure numbers. If you've got one, someone can probably guess what the next one's going to be, because it's deterministic. If you're generating session IDs, if you're using things that are doing with cryptography, you need to be using secure random numbers. Your system generates random numbers. Your Linux kernel will generate random numbers from system noise, so it's things like network traffic, device drivers. It uses things that's going on in the system to generate random numbers. Some machines have a hardware random number generator as well that can generate very good quality random numbers. You might find you run out of random numbers. Has anyone ever had that problem? I've certainly had it.
I've seen people who have.
Anyone else who's run out of random numbers? So if you're using the secure random number, you're generating huge amounts of random numbers, you have this thing called the entropy pool, and that depletes because you've only got so much noise going on, and there's only so much stuff the system can generate, and that can run out, and your system will slow to a halt. Because every time you try and get a number, it blocks.
Yeah, so usually when that happens, if you have physical access to your machine, just plug in a keyboard and just start typing randomly. For half an hour.
I was actually kind of looking at this. I was kind of curious about Amazon CC2, and I found this, which I thought was quite interesting. This is the website Games by Dice. Oops, let me go back. People were complaining their random numbers were not random enough, so someone invented this. And it scans the dice that get rolled with a laser scanner, and it does 1.2 million dice rolls a day. I was quite amazed by this. Yeah, it's doing scanning of the dice and rolling them.
Scanning your dice.
So if you need good quality random numbers, there's a generator. Okay, next slide. Okay. Cryptography. So again, this is probably going to be quite basic. I'll do it quite quickly. Okay. Two main types of cryptography. There's asymmetric cryptography and symmetric cryptography. Who hasn't heard of asymmetric cryptography? Have you heard of public key cryptography?
Same thing.
Public key cryptography?
Yeah.
Okay, right, so it's the same thing. So probably everyone knows this stuff. So you've got two keys, one's private, one's public. You can use the private key to sign things. The public key you can use to encrypt data that only the private key can read. So you've got two different keys. You keep the private one, you give the public one out, and other people can send you stuff that's encrypted, or you can sign things to prove who you are. So, quick example, you give a key out, someone signs something, encrypts something, you can then decode it. And there's a signature. So you've got a document, you can prove that you've signed that because only you could possibly do this. It's all based around, pretty much everything's based around this algorithm called RSA. It involves some complex maths I at one point understood and I've now forgotten. But the idea is that your private key lets you do something that if you didn't have that data, you could work it out, but it's going to take you until the sun burns out before you could ever work that number out. So it's all to do with complexity and time. And it's the foundation of pretty much every bit of web security that's out there. And all your SSL, HTTPS. There's been lots of things over the years about the possibility that's been cracked, and it's a kind of interesting topic. And we're not going to get into it because it's far too complicated for this session. So, generate an SSL key. You can use OpenSSL. I'm not sure AES is recommended, but that's on there. So you can use command line tools. You can generate a private key, and you can then generate a public key from that as well. And you can use the same stuff for generating SSL certificates.
Usually, you only do that when you're trying to generate certificate requests for a SSL. When you're buying SSL.
If you're buying an SSL certificate, your vendor will have some instructions on their website. Just follow them. You don't have to care. It's straightforward. So, symmetric cryptography. The difference here is you've both got the same key. In some ways, it's a simpler form of cryptography. Does anyone know what a one-time pad is? Is this a new term to people? So the way that I'd usually take it describing it is you've got a document you want to convert. You've got another set of random data. You can combine these two and you output the resulted data. So each character in this data you want to convert, you take one character from this and you combine them. And you can only ever use this set of data once. It's considered the most secure kind of form of cryptography. So if you want to encrypt 1 meg of data, you have 1 meg of random data you then mix. Anyway, real symmetric algorithms don't need that much secure data. You can encrypt a lot of data for a small amount of sort of secure key. It's much faster than asymmetric cryptography. If you're doing something like SSL, as far as I know, it's all like HTTPS. It's all going to go over SSL. It uses symmetric encryption for the communication. But you have the handshake is done using the asymmetric cryptography. So you do the certificate that is signed, that shows who you are. You can use that to encrypt some data. You send over a key, and then you start talking about symmetric cryptography. The most common thing you're probably going to see for this, the main algorithm for this one's called AES. I can't remember which one's just secure anymore. I know 128 used to be secure, but I have no idea if it is today or not.
AES it's recommended now. It's the fastest version of 3D.
Yeah, so every cryptography algorithm, check on Wikipedia for how it is today. And if you want to bet on it, you can go bet on it because it's probably changed tomorrow. So SSL certificates, probably most of knows about these. You apply to your certificate authority. They have a private key. They sign your certificate request and give you a certificate back. That then proves that you are who you are to some degree. The amount of proof that's in there only depends on how much checking they've done. You use this on your web server, you stick the certificate on there, you stick the private key on there, and you can then, your web servers then proves to people that you are google.com, it proves that you are who you are. And then the data from that point on gets encrypted. If your private key gets compromised, that's a huge thing. I'm trying to think, but if your private key is stolen, historical data is probably also vulnerable. So even like past information that was recorded could be decrypted by someone with that key. I think that's right. SSL.
Private key, yeah, that's what it
Probably,
does.
it probably. Anyway.
Depends on what's in your request.
So